Okay, so I guess I should begin now, like speak to these people right now. Okay, hey, uh, I'm very grateful to be here, but I'm more anxious and nervous to be here. That's my first time in a big event. So if you see me like turning red or start interrupting instead of talking, it's all part of the process. But if you just cannot understand me, just wave your hands and maybe we can cut this up somehow. So, for everyone in the back who can't actually see me, this is my face and this is me. I am Mike Chrysostomidis. I am a software architect at Stichiman for about 1.5 years now. And I've been writing code for a little more than 10 years. So this is the MK2200 by symbol. It's the first device ever hosting my code in production. It was a great piece of machinery with 128 megabytes of RAM. And it was running .NET 1.1 without the core part that might be used today. It was a horrid experience. So if we stick around that area 10 years ago, 15 years ago, we were somewhere like these fields of green on the left and red alert 2, as I chose to be my screenshot. And that was pretty much what we thought about when we were talking about software. It was our operating system and some games, and if you have a business, that tool that you run on, and pretty much that was it. So we had developers back then, so we were efficient, we were measuring productivity and all these things, but what actually changed? What's our state of our business today? To me, it's tempo. What actually comes here is that we use software all the time. Our profession is one of the most required ones nowadays. So more and more developers writing more and more code and more features are being requested and more change requests and more bugs. So the tempo to which we actually get down to write it and fix it and deploy it is much faster. Just think about what happened when you find a feature or a bug or a defect or whatever you call it. You usually go to your favorite ticketing system like Jira or Bugzilla or whatever, and you create the ticket, and about 5 minutes later, that's the reasonable time frame for this, you go and open your chat and say, hey, when's that going to be fixed? And that's why you created the ticket in the first place, so it's only reasonable. So the answer you might have is in about 6 months. Because as you know, our business has a biannual release plan since we're running waterfall. So you have around 5.5 to 7 months until you get this bug fixed. Okay, I made it into production. But that actually didn't go so well, so we went for Agile and Scrum and all these methodologies under the umbrella, and actually we can make it for the next sprint. I guess most of us are now under this mode, right? Show of hands? Good. So everyone else is doing waterfall still? Sorry, guys. But how could we actually go to right now? Like someone says to you, there's a bug, and you say, whoops, sorry, my bad, I'm gonna fix it right now. And that actually is the dreamland, I guess. Some lucky individuals already do it, but to us it's the dreamland. So this infinite loop we have of coding and building and testing it is actually there, and it's actually known for quite some years, but what actually changed is, again, it needs a new tempo. This cycle is smaller, and what we actually try to achieve as engineers nowadays is to actually make it smaller, nothing more. So we started using the word continuous because we want to run it all the time. We started with continuous integration, like that's your code and that's my code, and we're going to ship it today or next day into production. So we have to be aligned. So we use a distributed system like Git. And then we go to continuous delivery. Like, OK, that's around the 40th, 100th deployment that we're going to do. Let's automate it a bit, both this and our tests. And afterwards, it comes down to, OK, if I have adequate tests, actually more than adequate tests, and I can automate everything, why do I need this guy pressing the button to release once a week or twice a week or once a month? Let's do it every time we commit something. So what I want to talk about are monoliths, right? So how does a monolith not fit in this particular scheme? Monoliths can actually be continuous. If we say that the monolith is this elephant, then it actually moves. No one says that you cannot apply continuous integration or continuous deployment with a monolith. It's just pretty slow when you start, and it gets horribly slow as you continue putting more and more features. So even if you start, you have a slow tempo, and the tempo will be decreasing. So somewhere around here, we start talking about things, small things, usually called microservices. Back in the day, they were calling it software service-oriented architecture, to which microservice actually seems to be the right way to go. So what do these things do, and why is everyone so crazy about them? Actually, there are small, independent things that you can deploy and test. So when you go to deploying only one thing that actually needs fixing, or you can scale them at will without duplicating the whole system, you actually start using your production servers, which tend to be quite expensive, more efficiently. And then when you actually start to create microservices, you say, I want to be able to deploy this thing without deploying the whole system, the whole 400 microservices that I have. So here we actually try to do what every software engineer always has a struggle with. Maybe some of you don't. I still have this. It's how to create modular things and modular components and things that everyone can reuse without changes. And since you're actually creating something new every time you want to fix an issue, you go, hey, maybe my language isn't so good after all. Or maybe that 5-year-old thing isn't quite good. I can try something new because it's actually pretty small, and the feature might not be too important. So here's a great place of experimenting if this tool is the right tool for the job. So when you think about it, you actually hear a lot of people talking about it, and you're here. So should you do it? Now I should change the slide, I guess. But OK, it depends. It doesn't matter what I say now or what you heard or read in the blogs or Netflix or anything. It actually depends. If you do not need a continuous deployment environment, then you don't actually have to invest in it. It's not easy, so why bother? But we're going to go there. We can actually try to go to microservices one step at a time. To us, it was actually fundamental to try to solve this sooner rather than later. We couldn't scale with hardware. We had a complex system. Actually, betting, we'll discuss a bit more about this later on, but betting is actually a complex system. You cannot just copy the VM once and once more and expect that things will actually work. So some quick things about us. We are a game tech industry, meaning that we offer online services for betting and either sports or casino. We are operating in 5 countries under 2 different brands, Stichiman in Greece, where, as you heard in the morning, we're #1, hey, and Cyprus. And we also operate under the brand name Betano in Romania, Austria, and Germany. And look at this. Portugal, coming right up in the first quarter of 2019. So to us and what we do, and what's important for you maybe, we have 34 providers. We're not just one company, we're not one product. We actually integrate 34 different providers in order to provide, to perform our own business. And to do this, we have 67, maybe more, maybe less, but I think it's 67 integration points. I mean that even one provider can request more than one ways to talk to him. So right now we have 19 Scrum teams working over more than 7 other programming or front-end frameworks. And we use 4 different database vendors, being either relational or NoSQL. And on our busiest day, which is unfortunately Saturday evening, the day to which I want to be home with my cats, we have 65 to 70,000 concurrent customers. And we're not talking about 65,000 concurrent gets to our homepage, which is cast. It's 65,000 people looking at our software, at real time seeing what goes live in all the games that you want to watch, and betting to a place where we reached 1,200 financial transactions, not just database transactions, per second. So that's actually big, at least to us. Maybe you have more numbers and more power, but okay, this actually to us, it's really impressive and it keeps growing. So we started moving and migrating to microservices. And I like the word started because we just started it and we invested in it. We are actually trying to do it for a couple of years now, but we're not there yet. And it's really had costs and pain in order to do it. We have many, many bugs in order to do it, and we're still trying to do it. But I want to share some things that we actually did, that worked, and some that didn't. And I'm happy because actually this is the reason why I'm able to be here today. So, domains and entities, or domain and entities, however you want to call it. Everything you try to build, to model in your software begins with a domain. So without getting into specifics, let's call the domain, or the entity, actually the entity, Johnny. Here's Johnny. Johnny has a few distinct features. I'm talking about Johnny Depp now. He has cute eyes, right? He's kind of sexy, nice looking ponytail, and some other stuff. So we like the Johnny, and we start building software around Johnny. So the company grows, our people grow, more features, and somewhat about 2 years later, you gather around the table, all the developers and the other departments, and you say, let's discuss about Johnny. Tell me about Johnny. And there's something like this. Everyone starts having a different version, a different view of Johnny in mind when you get to your domain, because it's not just one thing that you do. It doesn't matter if it's overly complex or somewhat complex. At some point, you have various versions of your Johnnies in your software. And actually, every company, either purely technical or not, should undergo the process of redefining the boundaries of its application every couple of years. It doesn't matter if you actually start with microservices or anything, you're going to a point where your Johnnies have matured in a peculiar way and you want to measure them again and see what they should actually do. So what could we do and what we actually did? Okay, that one, the one with the red thingy, his forehead, it's actually the rockstar. When everyone is thinking about Johnny in our company, actually thinks of that guy with the red thingy. Okay, maybe that's a word for it, but... Thingy, thanks. And, okay, maybe him in the corner, he's actually obsolete. So maybe it's time to cut away some code written for him and some features and some database indexes because you actually don't need them. And those two, maybe some use them, but not all. And it's not used over time, it's not used consistently. So maybe you can start picking him away and putting him somewhere else. That's a pretty simplistic way to think about domain-driven development, but if it works. So talking about us now. To us, this was the main thing that we did. We have a wallet. The wallet meant that we have customers placing bets on live events. And everything went through the wallet. So when someone either placed a bet or when the event ended and the outcome of the bet was settled, everything went to the wallet. And as you can imagine, every feature that we started writing, every journey that we had inside our domain was somewhat surrounding the wallet. And at first it might be either modular and clean, or it might be messy, but it doesn't actually matter. What matters is that we started having notifications and reporting around wallet and building loyalty to reward our customers through our wallet. And well, the wallet on its own was pretty optimized and pretty cool. Really nice stuff. Other things started slowing us down. And if we wanted to scale this thing, we just had to copy everything again and again and again. But that's not actually scaling, because the buggy feature and the slow feature and whatever else will still be there. So our first step was simply putting it outside. So before talking about how to do it, actually this can happen in the same process. For starters, it can be in the same process, just to rethink about what's crucial and what not, when to return an OK and just raise a task or an event, and when to say, if this fails, nothing works. So that's another way to do it. If I cannot notify my customer, should I place his bet or not? Or settle his bet or not? Maybe you can actually do it and forego the notification if it's down for an hour. So somewhere around here, we talk about orchestration and choreography. Actually, my favorite thing to discuss. What does it say and how do we begin? When in process, when you have a single application where you put all your code inside, you actually have one point of orchestrating things. Imagine actually in the orchestra, when you have one conductor, one maestro, and going, now you go higher and you go slower, now I expect you to do this and you to do that. And that actually isn't scaling, because still you have a single point of failure. And even if you try to abstract it, it's still there, it's still in process. But when you start thinking about choreography in microservices, and services in general, and software in general, you go to the reverse thing, when if I can actually notify the rest of the system about what I did, maybe it's adequate. Maybe it's enough to keep the system running. So it's where you see your software evolving, since you're going to have more than one people and more than one team writing features for this. And they start to reuse things without having to go to the conductor, to the choreographer, and say, oh, hey, I want to put my feature here. I want you to call me when something happens. Because guess what? You're going to deploy both those things if you want to change either of them. So now I just reversed the previous image. And if we were trying to make it with orchestration, we have some APIs, right? Favorite HTTP APIs when you go call this and call this and call that, and maybe apply some cool and sexy circuit breaker that it's on the topic every day. But still you have one wallet for us, one application for you that knows too much. And it's his responsibility to retry, to know how much to retry and what's the acceptable timeout and so on and so on. So now you can try putting somewhere in the middle. And now all the wallet needs to know is this orange guy, who we'll talk about later. And what does it do is that that's actually RabbitMQ I'm trying to talk about. You actually put a message to RabbitMQ and say, hey, I've done my part, and here's what happened. And I put in a message, and it goes to Rabbit. Now the wallet can continue doing whatever he's doing, and the rest of the modules can actually do their part. And the nice thing about this is that you can reuse RabbitMQ or any messaging system you like. You might like Kafka or Azure Event Bus, I think, to do your thing. So a little bit under the hood about how this works, and it's almost common with any tool that you're going to use, is that your application, our wallet in the previous example, is the publisher. So he's done his part and publishes something. What he publishes is a message. The message goes to a topic. The topic now is just one place that similar publishers put similar messages, nothing more. Now, oh, and I like the thing that it does. Okay. Now you have one subscriber. In the previous example, it would be the notifications part, which creates a queue, plugs into the topic, and say, hey, give me any messages of that type, of your topic. And they just get copied over. So what do you achieve here? First of all, these two are actually now decoupled. The wallet, the publisher knows nothing, just the contract, which is the message. And the subscriber, same thing. If you wanted to alter a process in the meanwhile, you can just drop the topic or create a new topic, plug a new module in between, and say, now I get the messages, I change things, and publish them. And more or less, this will work. And the other great thing is that you have a new feature. So what do? You just plug the new subscriber and its queue to the topic. And that's all. Without having to think about, whoa, my publisher now needs to know and needs to load balance. No, nothing. All gets handled via messaging. So what would happen if that second feature you made is actually slow or uses a buggy feature underneath? More messages will pile up and the queue will become exhausted. But before that, you can just scale by adding more subscribers, which means that you can distribute the load inside a queue to more instances without actually doing anything. All you have to know is what's my queue name and what's the topic I'm subscribing to. No, go to this API or that API, or in the previous case, the subscriber would have to know something about the publisher if he wanted to post back and say, hey, I need something, or the publisher needed now to know more about how to load balance them. Or maybe you put a DNS inside, but again, it's something that you have to do, not in this case. So you start having more and more applications, either via messaging or not. So what you have, until you go to that nirvana, to that utopia where you have every database unrelated, is that you actually have multiple nodes trying to update the same thing. So when you're trying to validate and then act upon the validation, you just have to know that no one else is tampering with those data. We actually do it in database level with strict isolation levels, but when you start having more and more applications and scaling more and more, then what you're actually going to do? You're going to lock everything? Probably not. And while monoliths also suffer from this, microservices tend to do it more. So for us, everything that went, we actually don't have one wallet, we have multiple wallets, and we actually need to change this again, but we'll get there. What we do have is we have one wallet for sportsbook, and one wallet for casino, and one wallet for banks, which we deposit and withdraw money. So every transaction that comes actually gets stored to our primary database of SQL Server, but somehow we need to know that we're going to validate correct data. So since we're using SQL Server, we opted in for uplocks instead. It's the same under the hood locking that SQL Server uses. So what we do here is that SP_uplog gets to define one key that you will require. So it just might be wallet customer ID. So if you just say wallet customer ID, every other request that comes to any of your applications will just pass through because that lock, the new lock of the new customer is available. But if you go to that point of time where both wallets need to update the same customer, okay, one of them will have to wait, but not everyone. So while we do this on SQL Server level, we had another case of an external provider to which we started using and everything was great until one day he started saying, guys, you're sending me messages about the same customer and I just can't handle it, or at least not this here. So we had two options: not use it, not the case, or go with Redis. We actually use Redis for temp data when we need to store something for a customer for 10 minutes and then pop it without having to delete anything from databases. So since we had it, we had regular that's a difficult word. Can anyone say it for me? Redlock? Oh, okay. Redlock. So what does Redlock do? The same thing. You just say, this is my type of key for us, X provider customer ID. And again, in a first in, first out approach, he handles locking for us. If we get to the point where many applications will try to use the same lock for the same customer, again, they will have to wait. So no stress to SQL Server, we just had Redis, but the problem is waiting is not cool anymore. So how could we change our application to stop waiting for things, to doing concurrent things properly? This is actually I created this. I'm very proud of this. This is how hashing or sharding in RabbitMQ works, and I'm going to talk about RabbitMQ, but I guess Kafka already does this as well. So what you have on the upper side of the slide is that you have a queue. The queue is relevant messages for different customers. So let's say this is something where transactions, financial transactions. So what you can actually do is start hashing by the customer ID. And this is already in place for RabbitMQ, I think, in the version 3.6, the plugin. But you can actually do this on your own if you want more control over this. So what you do is say, I consume the messages and just create a new queue for its customer specifically. So now when I try to distribute the load, I distribute entire queues. And you assign it to a single process and go, hey, you have to do these 3 messages in sequence. But what you can actually do more is create more and more subscribers, so one can handle 40 different queues or 100 different queues in parallel, but for each message in its queue, it's in sequence. So if you want sequential processing of the messages, you can actually go for this. So you start having more and more microservices and more features, and data gets distributed over more and more either queues or databases or caching or whatever you have. So you get to the point where not all data are in the same place at the same time when you make a request. So when we try to explain eventual consistency, we just say too many hops or too many stops. Too many hops meaning that you have multiple systems, and when you go querying one of them, you just don't know which one has the data and which will get it either through synchronization or messaging or getting invoked via API or whatever. And the too many stops is that you begin having more and more caching layers. So you go, okay, this doesn't change as much. I can cache it for a minute or a second or an hour. So suddenly you don't actually know your data when you get them, at which point they're in, at which version, which view they're in. So a quick note about us is we offer live betting over live events, which means everything that happens is fed through a system, through a series of systems, which begins with a scout. The scout on the left is a person of a company actually being inside every stadium that any betting company offers live streaming. So what you have there is someone actually tracking every single incident that happens in a game, in all of games, either major or minor, and feeding through a tablet to his company. That then it goes to a company, call him the provider, and the provider collects them and aggregates them and pushes it to us. Now to us, we have two things in parallel, one being our system to the left, I guess, one or your right, one being the system actually displaying the updated values for our customers to see and bet on or use, and we have a trader who is also reviewing those data and what the algorithms produces and the game in real time. So at any time, he might notice something is wrong or something is delayed and actually pause. Imagine that the trading department in our company is around 100 or 150 people. It's one in 700 that we are. It's actually big, but when you come to thinking about eventual consistency, it's not only what you show, it's also what you're going to expect in your own system, in your own code. So this is actually a bug that we had in a few words. We had a child cast saying the event, like a specific game going today between two teams, and we cast it for a minute. Actually, we cast it for 5 seconds, but that's not the case. So suddenly, a new major league was created. It happens once in a month or once in a year. So a 10 minutes of casting is mostly, how to call it? It's more than enough. But it comes to this, that you have one API call calling child code of casting 1 minute, so you get one child, and you actually cannot find the parent. And that's actually a big problem to do it. You either have to start invalidating caches aggressively or start writing code defensively to say, okay, that should have been here, but it's okay that I don't have it right now. So you start having more and more microservices and more features, and it starts looking like this. That's your system. What you once had, which was one thing or 2 or 5 things contained, big and bulky, actually start talking to each other at their own pace, scaling at their own time, and you cannot actually follow this up if you're not prepared. The simplest thing to do is start correlating every request that you make. So in order to do this, every edge of the whole tree has to have a unique identifier, either being a cron job that just ran or something that a customer requested via API. You have to have control over your system in order to follow this up. So you have to actually look up some of the tools for distributed logging. We use Greylog, but Elk is a great alternate. So when you start correlating things and logging consistently and vigorously everything that you do in your system, you start seeing strains and bottlenecks in subsystems that you wouldn't expect to. Like when you have, for us, it's our front-end servers, and we notice that when a really weird small feature gets stressed, we start serving stale data to our customers. Or the other thing is that we had one API call to an external provider inside our web front, and it was pretty robust and cast up until we scaled from 10 to 20 front-end servers. So suddenly, the requester provider started timing out. They weren't caching their thing. So that was a great place to pick this up and remove it from a production flow and go to something like a microservice. A thing that actually did one thing, stored it somewhere, and created one application overlay to deliver any data that we had to our front end. And if it failed, it's okay. You either don't serve anything or serve a bit stale data, but that's up on you to decide in your business. So, you cannot actually go on a Saturday afternoon to write new features. You have to be proactive, and as you start scaling your application, you have to think at some places to be a bit defensive. I know that we already use Erlang as half our stack, and the motto of Erlang is don't code defensively. I actually like it very much, but in some places you have to just switch it off. You have to see what will happen even if it's a new feature or an existing one. We actually switched off one flow we had to one provider after 2 years and fallen back to nothing. Thankfully, we haven't deleted that code for switching off yet. But imagine that now we have about hundreds of, I think 400 or 500 switches and toggles inside our code base, inside actually our database, and reading it from our code base on a provider or platform or company, since we operate in 5 different countries, level. So we can say that we're switching this thing off only on mobiles, only on Germany, because that's where the bug actually is. And I know that we as developers are a bit attached to our code and our feature, and the team is really happy to release it, but sometimes shit happens. And you have to switch them off until you find a way to bring it back home. And for heavy-duty features, you can actually use this as a canary release and go, okay, what's our least stressful product or our least stressful country, and start releasing side by side. So we get here and we start using more and more services and different tools, and now polyglot is a thing, and we start using more and more languages in our system. But in order to achieve this, you have to start creating a more DevOps culture. That's another buzzword. A more DevOps culture to your company. And if I can actually leave this and leave, that's the thing. Because when you write software, when you write features, it's not only code. It's code and your database and your product and whatever the specs and the acceptance criteria were, or how you evolve them to be in your team. So you start to bring down the silos that you already had inside your company. So now it's not the developer or the programmer, it's the engineer who actually starts knowing about reverse proxies and about messaging that we saw before and about logging. It's actually my ownership. I have ownership over my feature. The feature is my own. It's my child. I created this for a reason. So I get from whiteboard to testable components to released products, and if it's switched off, maybe it's me who switched it off in production. That's actually how you're gonna go if you start deploying things when someone commits something. So what we actually do is stop having developers as people writing code and transform them into this. I actually like this very much. It's the power that comes when you have a new feature, or you start using Docker, or you start using reverse proxying on anything, and you go, damn, I can actually simulate the whole thing in my computer, and actually I can create something to give, to be released, and it's mine. It's my teams. It's not my companies. It's not somewhere else. It's not the admin's work to deploy it for me. It's mine. When it's getting released, I will be over this thing. I will monitor it consistently. And actually, that's how you grow. Even if it's microservices or not, you are something, you're someone in something bigger. Inside what you do, and you start sharing what your team does with other teams. even if it's a failure or a success. And you start having and using more and more tools to create something new. And if it's not okay, then it's fine because you learned something. So it doesn't actually matter if it's Dockerized or containerized. It doesn't actually matter if it's the bleeding new front-end framework that we're actually using Vue now, so it's bleeding edge. It's nice. But we also have Knockout, which is a few years old. And it doesn't matter how you actually try to do it, because Amazon and Netflix have their own specs and their own company and their own strategy and skill and people and budget. What you should do, in my opinion, is just try to improve, both you as developers and your colleagues and your team. And microservices will just be some tools. Thank you. I don't know if I left anything open for a question. Do I have time? No? Should I leave? Yeah. Oh, 2.
Stay here, stay here.
Oh, I'm going to stay here forever. I like this thing. Shoot.
You said this was the first time you've done a presentation like this?
Yeah, especially in not my mother language, which is Greek, but in English.
Right, okay. So your first time in front of an audience like this, who I gotta say, you're a great audience. They've been ever so nice to me all day. They laughed in all the right places. You did, it did a fabulous job, yeah? Yeah? I mean...
Okay, give it on. It's the first time. I have to do it again, I guess.
You really need to be on this side of it from time to time, because it's not as easy as Michalis made it look.
Did I?
Yeah, man.
Oh.
Yeah.
Hey.
And we're going to give you something to grow.
Is it edible?
It will be once the olives grow. Once the olives grow, take it home.
Okay.
Put it in grandpa's field.
Okay.
And that will be the beginning of your new
Thank you.
roots. Okay.
Thank you very much.
Thank you.